Determine, determining a rate law from initial rates. From last video, I taught how to determine rate, that is rate law or order of the reaction. In the nearly 7 points I given, if then it is considered as 8 point. Eighth one, determining a rate law from initial rates. So now initial rate data are listed in a table for the reaction 2NO plus H2 converted into N2 plus 2H2O. Initial rate data at 950 degrees Celsius are as follows. Experiment, initial concentration of NO, initial concentration of H2, initial reaction rate meter per second. Sorry, molarity per second. So this is M in molarity. Now this is molarity, this is also molarity. First experiment 0.200 and 0. This data I am not reading now. Now you can see this experiment 1 data, experiment 2 data, experiment 3 data. This is now A. What is the rate law? So first of all we have to find out the rate law. B. What is the value of rate constant and its units? C. What is the initial rate of formation of N2 when initial concentrations are NO 0.3 m and H2 0.150 m. So first I will try to calculate the rate law. So according to that rate law, equation is given 2NO plus 2H2 gives rise to, that is N2 plus 2H2O. This is the equation. Then rate law is represented as rate is equal to K, NO concentration power 2, H2 concentration power 2. But this is wrong way because this is experimentally determined. Therefore, this expression is wrong. Then which is correct? R is equal to K, NO concentration power X and H2 concentration power Y. So we don't know that what is the X value, what is the Y value. So how to calculate this X and Y value from this given data. So now I am taking these two experiment 1, experiment 2. These two experiment I am taking in consideration, and in this rate value is given here 0.125 is equal to K. NO constant. I am taking now equation 2 by equation 1. So equation 2 rate is a 0.125. NO concentration is zero point 0.4 concentration power X and H2 concentration is 0.122 power Y. Then this is equation 2. Now equation 1. Equation 1 is its rate 0.0313 is equal to K and its concentration is NO 0.2 whole power X and here 0.122 whole power Y. Now which is, this is cancel out 0.122 0.122. Next here this point cancel, 2 2 the 4, kk cancel, therefore 2 power x. Left side in the rate, this is cancel out. This is, if you are unable to calculate means point shift to here 12.5. Here also point shifted here, that is called 3.13. 3.13. So I will write here 12.5 into 10 power minus 2 divided by 3.13 into 10 power minus 2. So this 10 power minus 2, 10 power minus 2 cancel. Then this is nearly 3 fours are 12. Therefore, we have 4 is equal to 2 power x. Then this can be written as 2 power 2. 4 meaning 2 power 2 is equal to 2 power x. Then base same is there, means 2 is equal to which one? X. So x value is 2. Now, then next one we have to calculate y. Now, from this given data, we'll take consideration now experiment 2, experiment 2 and 3. Then we will consider here equation 2 by equation 3 or equation 3 by equation 2. Like this, anyone we can consider, no problem. So you will get the answer. Now I am taking equation 2 by 3. Then in experiment 2, I have these are the values. So 0.125, that is the rate, because we know the rate is equal to K NO concentration power X and H2 concentration power Y. Then in this, rate equal to 0.125 is equal to K and NO concentration is a zero point 0.4 power. Now x equal to 2, that also you can place, and y equal to 0.122 whole power y. Equation number, it means equation 2 is then divided by equation number 3, that is 0.0625 is equal to k. Its value is zero point 0.2 whole power, this is considered 2. Then this is H2 concentration 0.244. Like this we can consider, and power y. Now like this you can consider. Otherwise you take these, which one? These two, third and 1. Therefore, according this third and 1, equation 3 divided by 1, then I can write here equation number 3 is 0.0625 is equal to K, NO concentration 0.2 whole power 2, because already X we determined. Y value is 0.122 whole power Y. Which one this is? Sorry. This value is 0.244. Equation 3 this is. Whole power Y divided by equation number 0.0313 is equal to K, zero point 0.2 whole power 2 and 0.122 whole power Y. Now this is cancel out, cancel out. 0.2, 0.2 cancel. Now this is nearly in 12 2s are 24, means point dollar shifted means nearly 2. So this is 2 power y. This is point shifted here means 6.25. point shifted here means 3.13. So this is also nearly roughly 2. Then 2 power 1. Nothing is there in 2 power 1. Therefore, we can say this is 1 is equal to y. In previous word we have x equal to 2 and y equal to 1. Totally we determine the order with respect to NO and order with respect to y. So according to this one, we can write rate law R is equal to K NO concentration for X H2 concentration for Y and R is equal to K NO concentration power 2 and H2 concentration power 1. So 1 we determine this is a rate law. One answer, that is for A completed. Next, B. What is a B? What is the value of rate constant and its units? Rate constant and its unit. Now take any one of the equation. For example, we'll take equation 1 or equation 2. Then what will happen taking equation 1? Equation 1 rate is equal to K N O concentration power 2 H2 concentration power 1. In this rate value is 0.0313 is equal to K. NO concentration is zero point 0.2. Concentration for 2. H2 concentration is 0.122 power 1. Then K is equal to 0.0313. Rate unit is molarity second inverse. I forgot it. Molarity second inverse. And these are which one? Molarity. This is which one? Molarity. So denominator. Now I can write point 2. It means point 2 mean 0.04 is there. Square is there. 0.04 m square. You can see here 0.2 into 0.2. 2 into 2 4. Therefore 0.04. This is similarly into 0.122 m. Now you can consider here this m cancel out. Next, after this, we know point shifted to here, then it is 3.13. Point shifted to here, 12.2. Then this will be and this will 10 4 makes to 10 4 makes to cancel. This is in the 4. Okay. Then now this K is equal to 1 by 0.04 into 4 and this is called m square. Numerator second inverse is there. Now K is equal to 4 into 4, that is called 16. Then 1 by 0.16 m square, numerator second inverse. When you divide with this 1 by 0.16, then K is equal to 6.25. M square goes numerator m power minus 2 second inverse. So this is the value and its units. So this is third order, therefore this is a unit. Already we know that this one 2, this one 1. So x plus y that equal to 2 plus 1 is equal to third order reaction. So third order reaction this one. Then m in what is that? Mole 1 minus n and liter n minus 1 second inverse. If you put here third order, then mole 1 minus 3 is called minus 2. Liter 3 minus 1 is called 2 second inverse. Anyway, this is matching this value. Therefore, this is a unique and this is a rate constant value. What is the next? What is the initial rate of formation of N2 when initial concentration or NO is equal to 0.3 m and H2 concentration is 0.15 m? Now, according to this, we will calculate the initial rate of formation. Equation is 2NO is plus 2H2 gives rise to N2 plus 2H2. Now this we want initial rate of formation of N2. Rate is equal to d N2 concentration by dt, because positive this is a product, is equal to K, this is reactant, NO concentration power X equal to 2 determined already, and H2 concentration power 1. So now what we have to calculate according to this question, initial rate of formation. Initial rate of formation means this rate we have to calculate. So rate is equal to what we call K value. K value now only we determine 6.25, that is m second m square m inverse 2 second inverse. NO concentration given in the question, that is zero point 0.3, therefore 0.3 m whole square. H2 concentration given 0.15 m whole power 1. Now R is equal to 6.25 m inverse 2, means this m square, this m inverse to cancel. Therefore, we have 6.25, and next 0.3 into 0.3, it means 0.3 square, that is, I can write this is 3 into 3 9, then 0.09, and this is 0.15, 1 m is left here, 1 m is there, here second inverse is there, m second inverse, because we know the rate unit is a molarity per second. Okay. Now all these you multiply, then you will get the answer. After multiplying, we got 0.0865 molarity per second. This is the initial rate. So like this we can calculate the rate also, rate constant also, and each reactant respect to order also, that is expressed in the form of rate law. And one more point, 9 to 1 is order of the reaction also known from the integrated rate equation. Integrated rate equation or rate constant equation. From that also we can calculate the order of reaction. For example, we know the zero order reaction. Zero order reaction integrated rate constant unit is K is equal to R naught concentration minus R by T. If any nearly we are doing the experiment 1, 2, 3, 4, in that any two values, at least two K values are equal, that is zero order. From this equation, in case we are using the first order, in the first order formula, what is the K for first order is equal to, that is 2.303 by T into log initial concentration by after T time concentration. If here also nearly at least two K values, K1 and equal to K2, equal according to this equation, meaning that is a first order. Like this, any order rate constants are in any experiment 1, 2, 3 nearly equal 2 times or 3 times or all time equal, but at least minimum 2 time equal is there, meaning according to that equation, that order reaction. So by substituting this value, we are getting the K1 value, next K2 value equal is there, meaning that is a first order, and zero order equation respect to K are nearly 2 times equal in zero order, and next second order respective K is equal to 2 times, that is called third order. And next one, according to half-life method, already I explained. In that we know T half directly proportional to initial concentration power 1 minus n. From this also we can calculate the order of reaction. Now this is T half first time is equal to K R naught concentration power 1 minus n, T half second time K R naught concentration power 1 minus n. Equation 1 by 2, K cancel, and this is written as T half first time by T half second time is equal to, this is R naught is the first time, R naught is the second time. Then here also we will get here R naught 1 by R naught 2 is whole power 1 minus n. Then taking logarithm both sides, then log T half 1 by T half 2 is equal to, this can be written as 1 minus n log R naught 1 by R naught 2. Then n we want, meaning n key take left side, and n is equal to, later we can take first of all log T half 1 by T half 2 divided by log R naught 1 by R naught 2 is equal to 1 minus n. Then n is equal to 1 minus this log T half 1 divided by T half 2 divided by, actually this is like this representation, clear representation is 1 minus this one, and log R naught 1 by R naught 2. This is the explanation. We can get order of reaction from half-life and initial concentration. So totally now nearly 10 methods I given to determine the order. How to determine the order? All the different method I explained. So when order comes in your mind, all these 10 points should be at a time you should be remember.